Hi everyone. This is a video continuation of the blog article What I Wish Everyone Knew About SpO2 Sensors. In this video, we will demonstrate to differentiate between the good and the bad sensors. What you're seeing here is a specialized spectrometer which, which measures the red and IR wavelengths and can correlate and predict the accuracy of the SpO2 sensor. This spectrometer houses a Nelco-based module in which you can test all Nelco technology-based probes. Now, you may ask, how is this test acceptable according to the ISO 80601-2-61? No, it is not. But what we are doing here is, we are going to test 4 probes, one original Nelco probe, one breath-drone protocol, that is 80601-2-61 validated probe, and other 2 market-sourced probes manufactured by Chinese companies or traded by the Indian traders. Now let's get going. So first we are going to test the Nelcar based original probe, Nelcar original probe. Here it is. So this is called Optical Test. It's based upon a spectrometer principle where it measures the exact wavelength of the red and IR, and then it predicts the accuracy statement of a particular sensor. According to 80601-2-61, the probe should be within the plus or minus 3% of the arterial oxygen, or in other words, SpO2 should be within the plus or minus 3% of SaO2. Now you can see that it has been measured, and you can see an error table there, and I'm going to press the error table here. Here you can see, look at it. Now you can see that this probe would read 97%. When the patient has a 97% readings, the probe would show 97%. At 90 of patient readings, it would show 89. At 80 of the patient readings, this probe would show 79, and for 70 it would show 69, which essentially says that the plus or minus accuracy statement of this probe is 1%. So let's start testing the other probes as well. Get sourced probe. I'm going to start the test now. Again the optical test, again the normal test. The same process goes on. Now we can correlate how the earlier reading was and presently how the reading is. You can very well see the illumination of red LED there. It's too bright. It's going to be a lot of ambient light interferences. If I'm right, you can have a look at the error table percentage. It's almost minus 7%. That's really bad. That's really bad. You can see this. At 97, it's going to read 95. At 90, it's going to be 86. At 80, it's going to be 75. At 70, it's going to be 63. It's really a bad probe. We'll get going with the next probe. This probe is manufactured by Biometric Cables, and now let's get going. You can see the error table there. This probe has been breakdown protocol validated probe. According to 0601-2-61 tells us how to validate an SpO2 sensor in accordance with SaO2 readings. This probe reads -2, where you can see the error table. At 97 it's going to read 97, at 90 it's going to read 89, at 80 it's going to read 79, at 70 it's going to read 68. It's very well below the prescribed plus or minus 3% accuracy statement. Let's start the other probe. This is the fourth probe we are starting to test. Again, this is a market source probe. This is sure, what I would say, one of the worst sensors. It rates at -9% accuracy levels. It's too bad. You can see the error table here. At 97 it's going to read 95, at 90 it's going to read 85, at 80 it's going to read 73, at 70 it's going to read 61. So guys, get to know what exactly you are buying and how it could affect the patient safety. Thanks again. This is from Team Biometric. Bye, see you in other videos.